All right, so today what we're going to do is we're going to rig up a hydraulic shock like what you'd have in your car. I'm just going to show you how to do that real quick. Very simple setup here, and then once you're done, this is I've taken four of them. We're just going to do one today, but just to show you what's possible, I've taken four of them, and I put a control up top here, and you can see that as I rotate this control, these are all sort of squashing and I can also move it. You see that they stay on, they don't come off, and I could also do it from the bottom. So you can have this nice shock system going on, and you can move them. Obviously, if you go too far, they will separate. But if you stay within their limits, you can create this really nice animation here. If you constrain this to, one part of something and this to another part of something, then you don't even have to worry about them at that point. Like I've seen these used on like a robot, going from the neck to the head, where as the head turns, if the head turns, then these will stay correct like this. I think R2, not R2, but C3PO. I think it has them in his elbows or something like that. So there's no end to places that you can put these. If you do a lot of mechanical modeling and rigging and stuff and animating, these are really easy to set up, and they really give you that nice mechanical look. So what I'm going to do is, let's see. So we're going to use this file right here, and the link to this file is down in the description below. This one you'll notice has a spring. I just hadn't done it in that previous file. I'm going to show you how to make the spring compress correctly, but we'll start with the actual shocks themselves. Okay, so as I like to do with everything, I'm going to use joints to do this. You could do it with just the geometry itself, but again, I like to use joints because if I want to cache out this animation with a geometry cache, then I can do that, and what that allows me to do again is to completely remove the actual joints in the rig system from the file and leave behind geometry that's going to follow. Um, Using the geometry cache, the advantage of this is you have a much lighter file, because rigs can be very heavy. If you're just reading off a cache file or two, things happen a lot faster. It's a lot lighter, um, and that makes for much easier files to deal with. Okay, so what we're going to do is start by drawing the joint. So I'm going to come into let's go in the side view here. So we need a two joint chain aiming downward, and we need another two joint chain aiming upward. So let's start with this one up here in my rigging menu set. Okay, I'm going to go to skeleton, create joints. If we go in the tool settings, I'm just going to reset the tool. I'm using the joints at their default settings. I'm going to click once and hold down shift and click once again. It's going to give me a perfectly straight up and down joint chain. Okay. Then I'm going to select that and shift select this upper shock part here. Control 1 to isolate just those two things so I can see better. Now it's very important that this joint goes in the exact center of this ball and socket joint thing here. Okay, now the way I modeled this, I made sure that I had an edge going across halfway this way and one going across, and obviously one going across halfway this way. That just makes it easy for me to align this. If you don't get them aligned correctly, what happens is you're going to get a wobbly ball and socket joint here. So I'm just going to hold down V, and I'm going to pull this so that it snaps to the center, and then while with V still held down, I'm going to pull this down till it snaps to this cross line here. So what that should give me now is a joint that is perfectly centered to that ball and socket, or to the ball, I suppose I should say. So I'm going to hit Control 1 to bring everything else back. Now the length of the joint is not important. You can have this be as long or as short as you want. Doesn't really matter. Okay, so we're going to duplicate. So Control D to duplicate that joint. You'll see I have now a copy of that. I'm going to bring it down here, but I need to flip it 180 degrees in the y-axis. So if I go to Y and do 180, it's going to flip it up this way. Okay, and then again, I'm going to shift select the lower ball, the lower shock part here, and Control 1 to isolate that, to hide everything else. I'm going to hold down V, and I'm going to drag this down until it snaps to the center point this way. It's already snapped to the center line, to the center grid line here. Now I wanted to snap to this edge loop here. Okay, so that's what we have there. We can just simply freeze transformations right here, or you can go to modify, freeze transformations. Okay, to get rid of that 180-degree rotation. Obviously, with joints, the translates do not zero out when you freeze transformations because they represent an offset from the parent. Okay, so there we go. So we got two joint chains facing each other. Okay, so I'm going to take this top one here. I'm going to name it upper shock pivot JNT, upper shock pivot joint. And then this one is lower shock pivot JNT. Okay, so just so that I know what those are, let me open my liner. So there they are, those two joints. So the trick to getting shocks that work is using aim constraints. So an aim constraint takes the object that you're aiming and points it at another object. And no matter where that object goes, it'll continue to always point at it. We're going to do a double aim constraint, meaning that we're going to have this joint point to this joint, and we're going to have this joint point to that joint. Now they will always face each other. No matter which one of them moves, they will always be facing each other. Okay, so that's the trick to this, is using a double aim constraint. Okay, so what we're going to do then is we need, again, making sure that we have our rigging menu set open. I'm going to click the top joint, shift select the bottom joint, and I'm going to go to constrain, go in the aim, go in the options. Okay, and aim vector is the x-axis because joints by their default nature always point to the child along the x-axis. They always point along x. So that's my aim vector. That's the direction that I want to point. And then the up vector is the up axis for the joint, which in this case is the x-axis as well. So I'm going to put a 1 in here. So 1, 0, 0, and 1, 0, 0. The world up vector is always the y-axis, so we're going to leave that as y in there. And then everything else is pretty much at default. I'm going to hit apply. Okay. Then, now you notice there's a little bit of twisting there. That's fine. Then I'm going to select the joints in the reverse order. So I'm going to click on this one and then shift select the top one this time and just do the same aim constraint again. Okay, so now if I grab one of these and move it, notice how this joint continues to point at it. If I grab this guy and move it, notice how that one is also pointing. So it doesn't matter which one of these I move, they will always point at each other. You see, they both update. Okay, so that's pretty much the magic behind making shocks. And this can be used for like a sword in a sheath. So as a character starts to draw his sword out of the sheath, for the sword to not sort of clip out the side of the sheath, using these aim constraints really works. And then when the sword has cleared the sheath, you can have the aim constraint turn off. Okay, so now that we've done that, we can simply, with this joint selected, I can shift select this part, and I'm going to just do a quick bind skin. I'm going to reset. I'm going to go in here. I'm just going to reset my settings, then set this to selected joints, and pretty much everything else can be left to default. I'm going to skin that. So now if I move the joint, if I move the joint, you see the geometry goes with it. And same thing here, select the joint, select the lower part of the geometry. Notice I'm not doing the bases because these need to stay where they are. And again, just using the same settings, just hit bind skin. So now if I move this joint, you can see that now that goes. And as you can see, we have it pretty much working. Okay, it's always going to, doesn't matter which one of these joints you move, it'll always now work. Okay. So there we go. That was easy enough. Okay, so that's it. That's that's pretty much it. It's that quick to get a shock absorber type system. So again, if you do a lot of mechanical stuff, a lot of robots, a lot of cars, things like that, you just can't go wrong with the setup because it allows you to really rig those things up to make it look real. It just gives it a certain credibility when you have all that stuff in there. So a lot of science fiction guys like to use those. Okay, so next thing is our spring. Okay, the spring is very tricky. We want it to compress with the shock. As the shock comes down, we want that spring to compress. Problem is, we want it to either compress from the top or compress from the bottom. If I grab the bottom and move it up, I want that spring to compress from the bottom going up. If we grab the top part of the shock and move it down, I want that spring to compress from the top, right? Either compress from the bottom or compress from the top. So that's the trick. Maya has built in a helix, which I gotta remember where that is here. Nope, that wasn't it. Do I right click? Here we go. So if you right click on this shape, it's over here. Or you can go to create, polygon primitives, and helix, and it's going to create this sort of default helix here. And if you mess with the settings, so we can increase the height, we can, let's see here, if we increase the number of coils, and then if we drop the radius, make it thinner, so like a 0.15, right? You can start to see it looks like this. And with the height, you can see I can get it to compress. And it does it nicely, except it does it from the center, right? It's compressing from the center of the spring, which is not what we want. And we can't just scale it, because if I took this and I scaled it, I mean, I could hold down D and just move the pivot to the bottom, and I could get it to scale from the bottom. You see it's going from the bottom, but look at what's happening to my sprig. It's getting squashed, right? And this is not what we want. We don't want it to squash. We want this to stay round. So let's put like I don't know, 18 sides to that, so it looks more round. If I scale it, I'm squashing it, and notice how my spring is getting sort of flattened. That's not what I want. What I want is for it, if I do it with the height on the helix, you can see that as I compress it, this is still round. Okay, so this is staying round, but again, the issue with this is it's compressing from the center. So both the top and the bottom are coming to the center. That's, again, not what I want. So I'm going to need a different way to do this, okay, because this isn't going to work the way that we want it to work. Scaling is not going to work because it squashes the spring, even though I can move the pivot, but I can only move the pivot either top or bottom. So, that's not going to work. And then also using the height in the helix attributes here is not going to work because it scales from the center. So what is the solution for this? Okay, so we're going to use a couple deformers in here. First, we need to create a curve that follows the length of the spring. So I'm just going to select my spring here in Control 1, and I still have some history on there, so I'm just going to go ahead and delete the history on there. Okay, so I need a curve that I'm going to use to deform this spring. I'm going to use a spring deformer, or I'm going to use a deformer that relies on a curve to deform the object. So what I need to do is make that curve. Now the easiest way to make the curve, because I don't want to sit here and try to draw a spring-shaped curve. There's people that have written scripts, but even if I had a script to create a curve, I'd have to sit there and try to tweak it to match up to the shape of this spring. So what I'm going to do instead is just use the geometry itself to generate that spring. So if I go to edge mode and double click this edge loop, you'll see that I get an edge loop that goes up the entire length of that spring. Okay, and then I'm going to convert this edge loop to a curve. So I'm going to go to modify, convert, where are we here? Polygon, or is it polygon edges to curve? Let's go in the options here, and I want a cubic curve, okay, but pretty much I want the default settings. So if you reset it, you want the default settings. So I'm going to hit convert, and you'll see that now I have a poly to curve, which is a curve, and there it is right there. If I move it out of the way, you can see that it's just a curve that looks like this spring. So it's made exactly from this spring. Okay. So now what I want to do is delete the history on the curve. So I can hit this. So go to edit, delete by type in history. Okay. We want to complete, by deleting history, we disconnect it from this geometry. Because if I undo here to before we deleted history, if I go to this spring and move it, you'll see that my curve is going with it and it's getting messed up. That's because there's still a history connected to it. So if I select it and delete the history, that disconnects it. So again, if I try that again and move it, you'll see my spring is not going with it. Okay, we want to completely disconnect it from this spring geometry. Okay, we're going to call this spring curve. So spring CRV for spring curve. Okay, and then our next step here is to use a wire deformer. So I'm going to, the problem with this spring is that it's on the outside. The problem with this curve, I should say, is that it's on the outside of our spring geometry. We want it to be sort of centered. That's going to give us the best deformation. So what I can do right now, my pivot point's at the origin. I can just center the pivot, or you can go to Modify, Center Pivot. Okay, and now I just need to scale it in a little bit to try to get it closer to the center of the sort of tube of the spring. So I'm going to get my scale tool. Now, if I scale it on all three axes, you're going to see that it's going to start shrinking. And it's going to not be as close to the geometry as we want. So I'm going to only scale on the X and Z axes, right? This is the Z, this is the X. I don't want any Y scaling because I don't want it to get any shorter. So if I take this little green square here and let's go the other way, go in. So I'm going to undo that. Let's turn on our wireframe here. Let's try that again. If we go inward until it looks like, and you don't have to be super exact with this, just look at the end here, and if it looks like it's more or less centered, that's good enough. Okay, so we're centered into the geometry. Okay, so I just scaled in the X and Z axes right there. You see here, scale X and scale Z are the same, but scale Y is still at 1. Okay? So once we do that, we can just freeze transformations if you want. Guess that you don't really have to, but I like to keep things clean. Okay, so now we can go into the deform menu, and we're going to go to wire. So wire uses the spring to deform a piece of geometry. So if we click on that, you'll see that down in the bottom corner, it says select shapes to deform and press enter. If you look at when I put my mouse over it, it disappears. But once I move my mouse, you can see it says wire tool, select shapes to deform and press enter. So the shape to deform is our spring geometry. I'm going to press enter. And then it says select wire curves and then press enter to finalize this operation. So I'm going to click on the curve and then hit enter, and that should finalize that deformation. You see now we have a wire deformer in the history of the geometry here. Okay. So now that we've done that, if I select my spring curve here and move it and scale it, you'll see that it's now connected to the spring, and you'll see as I squash this spring, notice how I'm not getting, let me turn on my wireframe here, notice how it's staying round. It's not squashy like before. It's doing exactly like the helix was doing in the settings. So obviously this is not the way that we want it, but at least it's deforming the curve correctly. Okay, so I'm going to take I've got my curve selected. I'm going to hold down D, and I'm going to move my pivot right down to the lowest point on that spring. You see now if I do it this way, I can get that motion there. Okay. Okay, so now I need another curve. So that has taken care of deforming the spring without squashing it. But it's still not quite right, because right now, even though I've moved my pivot down to the bottom, it squashes great from the bottom. But what if I want to squash, what if I want to have the top be where it scales from, right? So this is not going to work exactly the way we want. Maybe I'll move it down just a hair more. Let's see here. Something like that. Just get it kind of close. Okay? All right, so we need another curve that will allow us to either squash from the top or the bottom. Okay, so what we need, let's see here. So I'm going to go in this view here. Okay, and I still have things. There we go. So I'm just going to hit Control 1 to bring it back because I had things isolated. So let's go into curves. Okay, I'm going to click on the EP curve tool, then I'm going to go into tool settings and go to linear. Okay, it's very important that it be linear. So I need this linear curve to run the length of the spring here. So, you know, you don't have to be super accurate, but I'm going to click over. Well, you know what? To get it to snap to the grid points, I'm going to, you can see I have a grid line that runs across here. So if I hold down X and click there, it's going to snap to that grid point. And I'm going to go to the top and hold down X and snap to that one and hit enter. Okay, now we got a new curve right here, and you might not be able to see it just because it's in the middle of everything. But what I can do here, let's go to a different view here. Hit Control 1. And I'm not sure. Oh, this is this guy from earlier. Okay. So let's select our curve here. I'm going to Control 1 just to hide everything else. It's going to be really hard to see this curve because it's just sort of hidden. It's so thin that it's hard to see with everything else. So I'm going to select the top point. So right click, go to Control Vertex, select the top point. Then I'm going to come in my side view here and bring that top point down to the top of our spring here, right about there. And then we're going to do the same with the bottom point and bring that up to the bottom of this spring. All right, so now that we've placed those two CVs, top and bottom, it's very important that we have only two CVs, okay? And this is why we did it as a linear curve, is that if we move these around, it's always going to be a straight line. It's not going to bend and curve like it would if it was a 3-degree curve. So being a linear curve helps with that. We're going to call this, so I'm going to go back in object mode here, and we're going to call this curve deformer CRV. So that's our deformer curve. So we're going to use this. So just like we took that original spring curve as a deformer right here to drive the geometry of the spring, this time we're going to take the deformer curve, that straight one, and use it to drive the deformation of the spring curve. So we're using another wire deformer. Okay, so again, we're going to go to deform, wire, okay, and again it says select shapes to deform and press enter. So I'm going to select my spring curve and hit enter. Then it says select wire curve and press enter. So I'm going to select this guy and then hit enter. Okay, so we've just done the same thing. Difference is we've done it, instead of doing it to the spring geometry, we've done it to the actual spring curve. Okay, so the next thing that we have to do here, we want to adjust some settings a little bit here. So in the spring curve, I'm going to select the spring curve here. You'll see that we have a wire 2. Now wire 1 is that first deformer. We want to look into wire 2. That's that latest one. And I want to set my drop off distance to about, I don't know, 10,000. Okay, so that's going to help this work a little bit better. So now if we take our deformer curve, and it might be hard to get, okay, there we go, I got it. If you right click, so now if we take the deformer curve and move that top CV up and down, let's go into wire mode here, or shaded mode. If we move that top CV up and down, we get this, right? So let's undo that, and then let's see if I can grab onto that bottom one. I'm going to hide my joints, select that bottom one, and go up. So you can see now that we're creating that where we can either deform it from the bottom or from the top. Okay, so whereas before we were stuck with going from the center and both ends coming in, Now we can, if this bottom section stays static, then we can move the top down on it. And if the top part stays static, we can move from the bottom upward. So we have now given ourselves that ability. Now, the problem right now that we're left with here is that in order for this to work, we need to be grabbing CVs, right? And CVs require that you go into control vortex mode and grab the CV, and obviously that's not very convenient. So I'm going to select one of the CVs here, and what I need to do is cluster it, so make a cluster out of it. So if I go to deform and cluster, you'll see that little C in there. That's our first cluster. And let's go back to our deformer curve here. Vertex. See, now it's a little bit hard. Control vertex. That's what we want. And then go to deform and cluster that one. So if I select the first cluster and move it, it's moving that bottom CV. If I select the second cluster, it's moving the top. So I don't have to go into control vertex mode. I can just grab the cluster and use it to move that CV. Okay, so very simple to do. So now that we have all this set up, it's very easy. What we need to do is, I'm going to bring back my joints here. We need to parent the top cluster under the top joint and the bottom cluster under the bottom joint. So the top cluster is cluster 2. We're going to parent this under the upper shock joint, and cluster 1 under the lower shock joint. And if your cluster 1 was the top one, then you can just parent that under the top thing. So you know, it's entirely up to you the way that you did it. So now if we grab this, grab the joint and move it, you'll see that we're getting our correct movement here on the spring. So the spring is going to compress with the movement of the shock here. So I'm gonna go back to my, I turned off the default material here. So as you can see, this is working pretty well. If I move this side to side, you'll see that the spring now goes with it, and so you can imagine if a vehicle was sort of driving along on a bouncy road, you'd get something like this, but also from the top as well, right? If I do it from the top, I get that spring acting correctly, and I'll compress it, and let's zoom in on it here to see the end of it. See how that's staying pretty round here. Okay, so that is working as expected. Okay, let me just undo back here to the default setting. Okay, so what you can then do to clean everything up in here, I'm going to select both these joints. Control G, we're going to call this group joints. Let's make it caps. Okay. And then I'm going to take this is all the geometry in here, so I'm going to just select all the geometry pieces, Control G, and name this geometry. And then I can take my curves here. I'm just going to take all these because these all have a hidden sort of base wire deformer here. So just take it all, Control G, and we're going to name this one curves. Okay, and then for all three of these groups, I'm going to select all three. I'm going to lock and hide everything. So lock and hide selected. So I'm just getting rid of those attributes so that they don't get messed with. And then I can just take all three of these and group them, and we'll call this one, I don't know, shock rig. Nope, let's switch this. Shock rig. Okay, and there we go. So now you have it all contained inside a single, you can break it down to a single node if you collapse it, and that'll work. Okay. And then these bases here, since they're not really connected to anything, what you can do is, let's see, so I'm going to select this joint here, the top joint. I'm going to duplicate it and move it up a little bit. Doesn't really matter where. And what I can do, if I come in this view here and Control 1, I'm going to isolate it. And then if we go into, so if I select this and come into the outliner and hit F, this is where it is. So this is the duplicate upper shock joint. We don't need anything below that, right? So we don't need the aim constraint, we don't need the cluster in there, and we don't need that second joint. So I'm going to get rid of that. Okay, so um, and we'll call this upper shock. We'll call this upper shock base joint. Okay, that's that guy. Let's do the same with the lower one. So duplicate it, move it down. Doesn't really matter how far. Open it up, delete everything beneath it. Okay, so this is our lower shock base joint. Okay, so lower shock base joint is going to be the parent of the lower shock pivot joint. So I'm going to parent lower shock pivot under lower shock base, and the same thing here. Upper shock pivot is going to be parented under upper shock base. Okay, so what that's going to do is if I take one of these and move them, you can see how that joint is staying vertical, and the lower shock pivot joint will rotate as needed to be able to point at the other joint. So what that's going to do now is I can take this guy here and shift select that base joint and do a, where are we here? Let's go in the rigging menu, set skin. Bind skin should be the same settings from before, so I'm going to bind that, and we can do the same up here. Select the base and the joint, and let's do a skin, bind skin. Okay, so now when I select this joint and move it, you'll see that my base is going to move, and that shock absorber lower section is just going to pivot inside of that cup. So it's acting just like a ball and socket joint. Okay, so let's check the top as well. If I select this joint and rotate it, you can see that that thing just sits in that cup and rotates like you would expect a ball and socket joint. So that if you connected this to something, that would move around, the shock would work, and then you could connect the bottom to something else and move it around as needed. And you see how that our spring is working. Now, obviously, you go too far, things are going to come apart. So it's up to you to make sure that you stay within the limits of that shock absorber. Otherwise, it starts to fall apart. Okay, so that's a limitation there. You could try to put limits on things. If you go in the attribute editor, you can turn on limit information and in the translate. I find that that doesn't really work very well, because there's always going to be certain positions that things are going to be in that might cause issues. So really all you got to do is just look at it as you animate, and you shouldn't have a problem. So there we go, we got a working shock rig, and all you got to do, you can now export this group here into a new file. You can you have multiple of them in there, and they should all work and have all the springs compress as needed. So as you can see, I could just take the whole thing, and well, I guess I can't because of the joints and stuff. So you got to be real careful with it. What we can do, if you wanted to be able to move it, then you want to make sure that you put a master control in there, and then you could put the joints group under that master control, and then you can move the master control. What you don't want to move is the geometry, because you want that to stay with the joints. Okay, so by translating this, you're moving the joints, and then you also move the geometry, so you get double transformations. If you want to avoid that, just put a master control on above the joints group, and then that should work just fine. Okay, so that is pretty much that. You could always extend this and make it cooler and whatnot, but this is a very sort of basic setup for a shock absorber, and that should give you some nice effects for the different things that you might do that have shock absorbers. Like I said, I see this mostly in like robots, because robots tend to have a lot of these things here, so having that on there will really be kind of cool. Okay, so yeah, I think that's the end of that tutorial. If you have any questions, let me know in the comments, and I'll see you in the next one.